Hi everyone, welcome back. Today we're doing Day 13 Abstract Classes in C++. This challenge builds on top of inheritance for Day 12, and in this case, we'll be introducing a new concept called abstract classes. Like what its name suggests, abstract classes are incomplete blueprints of classes, and abstract classes would typically contain methods that are meant to be overwritten or not implemented. So this is part of the object-oriented concepts, and this is one of the most important concepts alongside inheritance in production. So for this task, we will be practicing exactly that concept for abstract classes. And to be specific, we're given an abstract class called the book class, which is defined on line 8 to line 19. And in this case, this class contains an abstract method to be overwritten, which is on line 17 display. So our job for this task is to write a new child class that would inherit from this abstract class book and override two things. The first thing is to override the constructor that will take in 3 parameters, and in this case, this constructor has one additional input called price. We'll be defining a new instance variable or instance attribute on this myClass child class, and we'll be assigning that additional input from the constructor to that instance attribute. We will also be implementing the abstract method that was defined on the parent class called display, and we will be making it print 3 lines, title, author, and price. And that's pretty much it for this simple challenge. In this case, as usual, HackerRank is nice to take care of the input and output functions. So the title and author and prices, they're all ready in for us. And HackerRank also called the constructor for us and called the display method. So all we have to do for this challenge is to define this child class and just implement the constructor and override that abstract method. So with that, let's get started. So to get started, I will define the myBook class, and I will make it inherit the base class by defining a colon followed by the name of the parent class that I want to define. I then create the curly braces and finish it off with a semicolon at the back, just to start with the frame of this class blueprint. Now I will start to define the constructor, and just to remind you again, the constructor is the name of the child class itself over here. So in this case, it will take in 3 parameters, t, author, which will alias as a, and finally an integer, which is a price. And in this case, as usual, we will take advantage of the concept we learned in day 12 to reuse the constructor of the parent book class. So let's pass in the t and the a, and using the constructor, we will initialize the title and the author to be the input that we passed into it. And the last thing that we have to do is just set the instance variable price to this input t. So before we do that, let's define our new price instance attribute like this, and let's create a public scope over here and put our constructor as well as our abstract method to be under this public scope so that it can be accessed on line 52 to line 53. So now let's set our price to be equals to p, and with that we're done with the constructor. So the next step is to override our display method. So let's define the display method. In this case, the display method has a return type of void because all it does is just print out some stuff to the console. So let's do void followed by display. This method doesn't take in anything. It will just use the attributes that it already has to print out the title, author, and price. So let's print out the title. So let's do title followed by nline, cout, author, sorry, I guess I made a mistake here, followed by author and line, and finally for the final line, price, followed by toString. We are casting the integer of the price attribute before we print it out, and with that, we're done with this implementation. So let's try running this, and this passed, and let's submit this, and that's pretty much it. I made one additional little mistake, or I missed out a detail, but it would be nice to include this override method to tell C++ that you are overwriting the display method from the parent class over here. So there's 2 additional concepts which I guess is worth sharing, is that in this case we use this keyword called virtual. So this virtual keyword over here actually tells the C++ compiler to generate a vtable at compile time and create that vtable at runtime to keep track of which display function should be called if you happen to have a pointer of type book. But this pointer of type book, which is the parent class, happens to be pointing at a child class, which is my book. So if you had not defined the virtual keyword over here, calling display on that pointer, on the parent pointer, would actually call the display method on the parent class instead, which might not be what you want. So by having this virtual keyword over here, they create a vtable, and this vtable is used to map the correct display function to be used, even if you happen to have a parent pointer pointing at a child pointer. And if that's the case, then the parent pointer calling display on the parent pointer would correctly map the right display method using the vtable to call the child display method instead. So that was quite a mouthful, but if anything, I would say this is an auxiliary concept. We don't have to touch too much on that. And the second concept over here is the override keyword over here. By putting override inside your child class definition, this tells C++ explicitly that you are overwriting the display function on the parent class. And this override function lets us detect a few errors when we are programming. For example, if I misspell the name of the function that I wish to override, then override will be highlighted and it will hint to the programmer that, hey man, you made a mistake. You are not overwriting a function. You probably made a mistake in naming your function. So this is the first benefit of override. The second benefit is that if you happen to not put the virtual keyword in front of the function to be overwritten, then override would highlight that as well. But take note, having this virtual keyword does have its drawbacks. And I guess if you're in high frequency trading or if you require your runtime and memory to be very specific, I guess if you do low level programming, then in this case, using this virtual keyword does have its drawbacks. So to be specific, you will use more memory at runtime to use that vtable to map, that will be used to map which function to be called on the child class. And the second is there's some additional runtime expense to correctly get the right display method. But with reference to to a YouTuber channel who gave a very good explanation about this concept, that cost is quite negligible. So with that, I would personally choose to use these two keywords because it helps with readability. And I guess in most cases, the time of software engineers is more important than just a little bit of runtime cost. But that's up to debate, and if you wish to disagree, I would recommend to give us your perspective in the comments, and I would love to learn from you. And with that, that's pretty much the end of this video. If you love this, please give us a like and subscribe, and we will see you in the next video.